Lesson 11.6, Inferences from Tables. Given selected values of the twice differentiable function f, which of the following choices could possibly be true on the entire domain between 3 and 9 for our x values? So twice differentiable just means it's continuous because we can take the derivative twice, so there's no discontinuities or jumps. And again, this is possibly true. We can't know for sure. But what I know is there's a point at 3, 8, 5, negative 4, 7, negative 13, 9, negative 19. And so what I can do is find the average rates of change. And sometimes you'll see AROC, average rates of change, which is just the slope. And slope is our tangent lines. And so that's what they're wanting us to figure out, is what's happening to the average rate of change. And that goes from point to point. So it's the change in y over the change in x. Remember, y2 minus y1 over x2 minus x1. So what I want to think about is, what's the difference between 8 to negative 4 on a number line? Looks like from 8 to 0 would be going back 8, and back 4 more would be negative 12. 3 to 5 is increasing by 2. So I would want to divide to get an average rate of change of negative 6. Then I would want to say, okay, well, negative 4 to negative 13, that's going back 9. 5 to 7 is dividing by 2 again. That would be like negative 4.5. Negative 13 to negative 19 would be going back 6. And then again, change in x is 2, so negative 3. So I know that all my slopes are getting negative. So that's got to be saying f prime is negative, not positive. And then look at the trend. Negative 6, negative 4.5, negative 3. Are my slopes getting bigger or smaller? Well, they're negative. So negative 3 is actually smaller than negative 6. So my slopes actually are increasing. Even though they're negative, the trend is it's going to keep getting bigger and bigger and bigger. So again, just a possibility. We don't know for sure. Number 2 is the same thing, just a different notation. So see how they've got f prime of x and they've got greater than or less than or equal to 0. That's what we're looking at, is just this negative, positive, increasing, decreasing. So I would want to find the average rates of change here. So 19 to 30 is increasing by 11 while x is increasing by 2. That would be about 5.5, or not about, but 5.5. 30 to 38 would be 8. And again, divided by 2. 38 to 43 would be increasing by 5 divided by change of 2, be 2.5. This time all my slopes are positive, so I want to pick the one where the first derivative is greater than 0. Then I am also getting values that are getting smaller, so I would be getting or decreasing for my second derivative, so that would be is less than 0. Number 3. Cannot believe I spelled right wrong. Fix that. It says, given selected values of the twice differentiable function f with f prime being negative, a single number that could possibly equal the value of f prime of 7 is what we're trying to figure out. So we want to find our average rate of change because we are trying to figure out an exact number that could be the slope at 7. And so right now, all we know is there's a point at 718, but we need to find the rates of change so we could get a good number for an estimate. So my average rate of change here would be from 16 to 18 is going up by 2, and then this is going up by 2, so it would be 1. Then I would have from 18 to 18, that's not increasing at all, that's 0, divided by 2, which is still 0. And then 18 to 16.5 is going down by 1.5 divided by 1, which is negative 1.5. But at 7, let's see, we're looking here. So we're going to look here and here. So from the left side and the right side, we've got different slopes, and I want a slope for 7, and it tells me that the second derivative is negative, so it makes sense that this is decreasing in value. So I just want to pick something that's between, that's less than 0 and greater than negative 1.5, anything. So it could be negative 1, it could be negative 0.5, It could be negative 1.49, anything that falls in that range. Okay, number 4. Says selected values of the twice differentiable function are shown with f prime of x, so the first derivative needs to be greater than 1, the second derivative needs to be negative for all x on the interval 0 to 9. Which of the following values could potentially be the value of a? You could mathematically figure this out, but I think the better option would be to guess and check. So let's try first having a 41 in here and seeing what happens. And so let's find the average rate of change. So we would have 10 to 31, that's a difference of 21 divided by 3, which is 7. 31 to 40 is 9 divided by 3, which is 3. 40 to 41 would be 1 divided by 3, which is a third, or 0.3. Did that work? Did that get a slope, a first derivative that's greater than 1? No. So 41 is out. We don't even have to check. Is it negative? No. So now I would try it by plugging in the 44 and seeing if it works. So let's put a 44 in here instead. 40 to 44 would be a difference of 4 thirds, which is 1 and a third. 1.3 repeating. And so that is greater than 1. Oh, and I shouldn't say negative. Sorry, that the second derivative means it's decreasing. Did it get a number smaller than the 3? Because remember, this one was out. Did it get a number smaller? Yes, it did. So that would be 2 only. So all I would do is just plug in your different numbers and see if it meets the criteria that it's supposed to.